Have you ever just looked at the world and wondered why some things work? They just hold together, while other things just spectacularly fall apart. Well, we're about to dive into some incredible research that gives us a whole new way to understand stability and collapse, not just in nature, but in pretty much everything. Let's get into it.
I mean, think about it for a second. A sports team, a project at work, heck, even a friendship. Why is it that some of them can handle all kinds of pressure and just keep getting stronger, while others that seem totally fine on the surface just suddenly implode? It turns out it's not just about luck, and science is finally giving us a way to measure the hidden forces that are really running the show. For the longest time, we've kind of thought about success or stability as being all about brain power. Having a smart leader or a central computer making all the right calls. But a much newer and frankly more powerful idea called embodied intelligence says, hold on a second. It's not just about the brain. Real stability, real intelligence, comes from a delicate balance between a system's mind, its physical body, and the world it lives in.
Now, that idea feels right, doesn't it? It's intuitive, but it also creates a huge problem. How in the world do you actually measure that balance? How do you put a number on those invisible forces that keep something from flying apart? It's one thing to feel it, but it's been almost impossible to actually pin it down with science. Until now.
And look, this isn't some brand new out-of-the-blue thought. Researchers have known this for a while. As the folks behind this paper put it, things hold together not just because of some smart internal computer, but because of a team effort between the body, the brain, and the environment. The real problem has always been that we just didn't have the math to describe it.
And that brings us to the core breakthrough, the absolute game changer here. Can you take this really complex, kind of fuzzy idea of balance and boil it all down to a single, understandable number? A number that could tell you, hey, this system is healthy, or watch out, this thing is about to go off a cliff. Well, the research we're digging into today says yes, we can.
So, to get to that one magic number, the researchers first had to take apart the very idea of the work a system does just to exist, just to hold itself together. And what they found is that all this work can be broken down into three fundamental kinds of energy. This is the tool they built to do it. Okay, don't let the name scare you. The ΔΩ Coherence field. The easiest way to think about it is like a special set of glasses, a mathematical lens, that lets scientists see exactly how these different energies are flowing and pushing and pulling inside a system, and most importantly, whether they're in balance.
All right, so the first type of energy is kinetic. This one's easy. It's the energy of action, of doing stuff. It's the forward momentum, the change, the raw agitation in a system. Think of it as the go, go, go energy.
The second is potential energy, and this is pretty much the opposing force. It's the energy that holds things together, the structure, the organization, the rules. It's the internal glue that creates order and stops everything from just flying apart. It's the, whoa, slow down energy.
And then there's the third one, which is super interesting because we don't often think about it this way. Memory energy. This is the energy that's basically stored in a system's past and in its physical shape. Think about the muscle memory of a tennis player or the specific shape of a shark that's been perfected over millions of years. It's the wisdom of the past, physically baked into the present.
And this, right here, brings us to the secret sauce. A healthy, resilient system isn't one where one of these energies is the boss. Nope. It's one where all three, the action, the structure, and the history, are in a beautiful equilibrium, each doing about a third of the work to keep the whole thing running smoothly.
But okay, knowing the types of energy is only half the story. The next question is, where is all this work actually happening? The researchers figured out there are four key places: the system's physical shape, its morphology, the stuff it's made of, its materials, its brain or central control, and of course the environment it's sitting in. A really healthy system spreads the workload across all four of these too.
So, let's recap. We've got three types of energy and four places where that energy can do its thing. By measuring the balance across all of these factors, the researchers finally built what they were looking for from the very beginning: a single, incredibly powerful number that can actually predict when things are about to fall apart.
They call it the Ecological Balance Index, or just EBAL for short. And this one number, it captures the whole story. It answers one simple question: how evenly is the work of staying alive spread out? Is everyone doing their part, or is one piece of the system doing all the heavy lifting? So, if a system has a high EPAL score, that's fantastic news. It means the work is distributed beautifully across all its parts. The system is coherent, it's stable, and most importantly, it's resilient. It can take a hit and keep on ticking.
But a low E-ball score, well, that's a 5-alarm fire. That is a massive red flag telling you the system is dangerously out of whack. One part is being overworked, overstressed, and is about to break. When you see that low number, collapse isn't just a possibility, it's pretty much just around the corner.
In fact, the paper proves this with a really powerful rule. It basically says, if any single part of the system or any single type of energy has to do all the work, say it approaches 100% of the load, the whole thing will break. It is a mathematical certainty. This is the ultimate scientific argument for why you should never, ever put all your eggs in one basket.
So you can see this isn't just some neat theory for a science journal. This index has huge real-world applications. It gives us a brand new lens to look at almost any complex system you can think of, from a tiny robot to an entire organization. Let's look at what that actually means.
Check out these examples. In a person, someone stuck on a past trauma is totally dominated by memory energy. In the world of AI, you might have a robot that's really clumsy because its designers made the control system, the brain, do 100% of the work instead of giving it a better body. Or think about a company that is way too centralized. It's not using the strength of its morphology, its people, and its structure. In every one of these cases, eBall can diagnose the problem.
And that's really the ultimate power here. The Ecological Balance Index isn't just telling you the future. It's a diagnostic tool. It's like a blood test for a complex system. It doesn't just tell you if your company or your project is sick, it tells you why, by pointing to exactly where the imbalance is.
Which of course brings us to the final and maybe the most important question of all. This isn't just about robots and companies. Think about your own life for a second. Your job, your health, your relationships. Whereas one part doing all the work. What system in your world might be dangerously out of balance?